Hello, this is Professor Maria Luisa Bainyo Salingay, inviting you to join me in my short discussion on compounds, anions, and cations. In a compound, the molecular formula indicates the actual number of atoms in a molecule, while empirical formula gives the relative number of atoms in a molecule. Subscripts are the smallest possible whole number ratios. For example, empirical formula HO has a molecular formula H2O2, which is peroxide. Empirical formula CH could be C2H2, which is acetylene. Ionic compounds is a combination of metals and nonmetals, wherein the metals are the cations and the nonmetals are the anion. For example, sodium chloride, the sodium is the cation with a positive charge of 1, and chloride, a nonmetal, is an anion with a charge of -1. Covalent compounds are generally composed of nonmetals only. For example, HCl or hydrochloric acid, CH4 methane, and CO2 carbon dioxide. There are guidelines in writing and naming ionic compounds. The first one is you have to be familiarized with the names and symbols of elements in the periodic table. For common cations, elements in group 1A has a charge of +1, group 2A a charge of +2, and aluminum in group 3A a charge of +3. These were also explained in my discussion on periodic table, wherein you can predict the ionic charges as illustrated here. For common anions, element in group 7A has a charge of -1, group 6A a charge of -2, and group 5A a charge of -3. These are shown in this periodic table. If you notice, group 8A has no charge because these are inert gases. For transition elements, as discussed on my previous video on periodic table, most of them have more than one positive charges. Cobalt, for example, has charges +2 and 3. It will be written as cobalt Roman numeral 2 and cobalt Roman numeral 3. These are also same to transition metals like chromium, copper, iron, lead, manganese, tin, and so with other transition elements. Take note also with other cations like silver, zinc, mercurous, mercuric, and ammonium. For other ions on the list, there are common binary anions that may have the same charges but named differently because of different number of oxygen. For example, NO2 -1 is named nitrite, while NO3 -1 is nitrate. For ClO -1 is hypochlorite, with one oxygen more is chlorite, another oxygen more is chlorate, and lastly ClO4 -1, which is 3 oxygens more than the original hypochlorite, is perchlorate. The same with the previous example, but this time another halogen element, bromine, instead of chlorine. For BRO negative 1 is hypobromite, with one oxygen more is bromite. Another oxygen more is bromate. And lastly, BRO4 negative 1, which is 3 oxygens more than the original hypobromite, is perbromate. Second guideline, write the metal first in writing compounds. Charge written as superscript. Careful with metals of different charges like iron 2 or 3. There are also polyatomic cations. These are non-metals but positively charged like ammonium and hydronium. Third guideline, non-metal is written after metal. The charge is written as superscript. Non-metal can be monoatomic like chloride, fluoride, oxide, or sulfide, or polyatomic like hydroxide or cyanide. Non-metal could also be oxyanion that ends with ATE and ITE with one oxygen less but with the same charge like nitrite, nitrate, sulfite, sulfate, chlorite, and chlorate. Non-metal could also be more oxygen atom like hypochlorite, chlorite, chlorate, and perchlorate. Non-metal could also be anion plus hydrogen like hydrogen phosphate, dihydrogen phosphate, and hydrogen carbonate. Fourth guideline, remember the 7 diatomic elements. These are always written as 2 atoms. These are hydrogen, nitrogen, oxygen, fluorine, chlorine, iodine, and bromine. Let us go to the guidelines in writing and naming ionic compounds using crisscross method. For the first example, lead and oxygen, the charges are written as superscript Pb plus 4 and O negative 2. Then transpose the superscript of the cation to become subscript of the anion and vice versa. So it becomes Pb2O4. Take note, no more charges. In transposing, you cancel it out. Then reduce to lowest ratio. And no need to write 1. So it becomes PbO2. Middle example, Ca plus 2 and NO3 negative 1. Then transpose the superscript of the cation to become subscript of anion and vice versa. So it becomes Ca1 and open parenthesis NO3 close parenthesis 2. Reduce to lowest ratio, no need to write 1, so it becomes Ca open parenthesis NO3 close parenthesis 2. Last example, Mg plus 2 and OH negative 1. Then transpose the superscript of the cation to become subscript of anion and vice versa. So it becomes Mg1 and open parenthesis OH close parenthesis 2. Reduce to lowest ratio and it becomes Mg open parenthesis OH close parenthesis 2. Let's go to naming and formula writing of molecular compounds. First, element located in the farther left of the periodic table closest to the metals is written first, except when it contains oxygen and halogen except fluorine. Oxygen is written last. Second, if both elements are in the same group, the element closer to the bottom is named first. Third, add IDE ending on the second element. Fourth, Greek prefixes indicate the number of atoms in each element. For example, mono for 1, di for 2, tri for 3, and so on. For compound P4S10, it is named tetraphosphorodecasusulfide. For NF3, it is nitrogen trifluoride. Fifth, the A or O of the prefix is often dropped. When prefix ends with a vowel and the second element begins with a vowel, for example, in Cl2O, dichlorine monoxide, or in N2O4, it is named as dinitrogen tetroxide. Mono is never used with the first element. Like for example, in NF3, it is named nitrogen trifluoride. Now let us go to the guidelines of naming and formula writing of acids containing anions. First, ending with IDE are changed to IC. Prefix hydro and add the word acid. For example, in HF, it is hydrofluoric acid. HCl is hydrochloric acid. Second, ending with ITE change to OUS, and ATE ending change to IC. Retain prefixes in the anion and add the word acid. For example, in HClO, it is hypochlorous acid. HClO2 is chlorous acid. HClO3 is chloric acid, and HClO4 is perchloric acid. Another example, HBRO is hypobromous acid, HBRO2 is bromous acid, HBRO3 is bromic acid, and HBRO4 is perbromic acid. That is all for today. I would advise you to do some exercises on naming and formula writing. If you have comments, feel free to contact me on the following medium of communication.